All right, so this is a super simple and very practical talk in which I'll discuss 5 ways of making your benchmarks better or more relevant, more interesting. And it's really a very, very simple talk. It's going to be no references to Wittgenstein, no nothing. I'm basically just going to list those 5 ways, provide a couple of references, and that's pretty much it. In fact, I'll give the entire talk away on the first slide, um, which is this one. It's kind of a spoiler giving away that I'll talk about the idea of adding timestamps to your benchmarks, adding information about writer demographics and annotator demographics. I'll talk about the value of re-annotating the data, and I'll talk about the value of not just having a single benchmark, but having multiple independent benchmarks. Sam and George recently put a really cool paper on arXiv called "What It'll Take to Fix Benchmarking in NLU." And given that Sam is also talking at this workshop, and given that the paper is kind of fresh off the press, I thought I'd relate what I'll talk about here to their paper. Their paper is also very practical, and there's this very practical summary of the entire paper on the first page. The first thing they mention in that summary is how it's important that good performance of a benchmark or on a benchmark should imply robust in-domain performance on the task. This is obviously something that I agree with in general terms. One thing I'll talk about here, one of the 5 things, is the relevance of, or the value of adding timestamps. And this is sort of complementary to what Sam and George are talking about here, because robust in-domain performance is a moving target, and that's the motivation for adding timestamps to benchmarks. So what a domain means, what's in a domain, changes over time. And I'll briefly talk about that. So I think this is an important sort of addendum to what Sam and George discuss. There's a little bit of friction, perhaps, between what I'll talk about and what Sam and George talk about. And this shows up in the second bullet point here, where Sam and George say benchmark examples should be accurately and unambiguously annotated. I actually tend to think that the notion that we can do that is a bit of an illusion, and that there's often more value empirically in having multiple ambiguous and inaccurately annotated re-annotations of the data. And this is something that I'll talk about. Third point here is benchmarks should offer adequate statistical power. This is, of course, something that I agree with. I'll have a little bit to say about that, but not too much. And I just want to point out that there's a couple of really cool papers in that space that came out sort of within the last year. Card et al. And Rodriguez et al. In particular. Fourth point is benchmarks should reveal potentially harmful social biases in systems and should not incentivize the creation of biased systems. Of course, I totally agree with that, and I think what I'll say here is sort of very much along the same lines, but also kind of complementary to the standard way of talking about bias in NLP, which is very much focused on biases in representation. So the representation of gender, for example, in language models, or the representation of age. I'll talk instead about the importance of bias in terms of the writers who produce the texts in our training data or our evaluation data, the demographics of the annotators, and the importance of thinking about all those dimensions, um, along with the representational dimension. Okay, so basically, I'll talk about 5 things here, and I think they're largely complementary um, to what Sam and George talk about, and therefore 4 bullet points. If you want to stir up a little bit of friction, it's going to be between sort of what I'll talk about as re-annotation and their sort of second bullet point here. I think there's an interesting discussion potentially there. Um, okay, so the first thing is this idea of adding timestamps to your benchmarks. Basically, timestamps just recording when the texts were produced. Now, the first time I heard, or kind of, I started thinking about temporal drift and the importance of temporal drift in NLP was seeing a talk by Abby Levenberg, who was a PhD student at Philip Kohn doing machine translation. So Abby had these really cool graphs where he would basically just record the performance of a machine translation model for, say, English German, trained on sort of a slice of Europol, say Europol 96 or something, and then he would just sort of evaluate that model on Europol 97, 98, 99, etc. And he would just have these sort of curves that would document the performance drop over time. And I thought that was super cool. Like, really the first time you would see sort of the declining performance of an NLP system over time. It took me a couple of years to get around to working on that, but in about 3 years ago, I had a master's student. His name was Jan, who wanted to work on polarity shifts and their sort of importance for sentiment analysis. So what Jan ended up doing was sort of backwards classification for sentiment analysis, and he would have these sort of this sort of temporally split data. He would have training data back in time and newer test data, but then also based on that time-stamped training data, he would train regression models to predict the polarity of individual words. So the final backwards model would have adjusted coefficients informed by these regression models. And this actually ended up working really well. So you would basically have a model trained on, say, Amazon reviews from 2008 to 2013 or something. You would evaluate that in model in 2015. But based on those 5 years of historical training data, you would basically stipulate the polarity of the individual words to 2015 and use the corresponding coefficients of your stipulations rather than just the maximum likelihood estimates. Last year, I was visiting researcher at Google and worked with Sebastian Ebert and Jasmine Bastings and Katja Filipova in this group that Slav is starting up in Berlin. And we wanted to do something together just to kind of get things off ground. And I suggested that we did something in the space. So the paper that we wrote was published at the ACL this year. It's called We Need to Talk About Random Splits, and is a reply to a paper by Kyle Gorman and Steve Bendrick from ACL 2020 called We Need to Talk About Standard Splits, in which they argue that kind of standard splits are somewhat arbitrary and we should instead use multiple random splits. Now, kind of our problem with that, and this was really sort of after thinking about things like temporal drift, is that random splits really are only meaningful if you assume that there's no temporal split, right? So you assume that data is perfectly representative of the data that you'll see at test time. We ran a bunch of experiments to kind of quantify how badly you overestimate system performance if you do just that. And as a side effect, we also had very direct comparisons of the importance of temporal drift relative, even at very small scales over small amounts of time, relative to other forms of bias. For example, we could show that if you train a system on very short sentences and evaluate it on long sentences, obviously performance is going to drop compared to sort of also evaluating on short sentences. But that drop is typically smaller than the drop you see just sort of sampling evaluation data later in time. And we found that to be really interesting. So all of this is only, like, this kind of research is only possible if you have timestamps in your data. If you can say when the data is from. So that information is sometimes available. Even the English Pen Tree Bank, for example. For the tree bank, the data is out there. The timestamps are out there. They're not widely available, but you can find them. So sometimes it's just a matter of keeping this information around. But basically, what I want to say here is, like, when you create a benchmark, that data is potentially very, very useful. Another thing that's super useful is the demographics of the authors of the texts. So Dirk Hovey and I first looked at this back in 2015. I think this was ACL in Beijing, where we evaluated part-of-speech taggers on texts that we had annotated, written by people of different age groups and genders. And we were able to show that state-of-the-art part-of-speech taggers work best for old men, and there were significant biases or performance differences with respect to age in particular. And then Anna Jurgensen, who was a master's student of mine, were able to show kind of similar performance differences for Twitter part-of-speech taggers relative to race. Now, recently we've done more work in this space. So in Coastal, there's people currently working on argument mining, summarization, genre classification, document classification, handwriting recognition, and sort of across different demographic groups. What I want to talk about here is some work in the context of language modeling and some work on sentiment analysis. Victor Sang is a visiting PhD student in Coastal, has evaluated a lot of language models and how they align with the lexical preferences of different demographics. So what we have is a lot of Cloze data for different demographics. So basically human continuations of sentences like after waiting 3 hours, Cal whined and started to. So you can compare that with language models. So for example, here on the right hand side, the upper half is bar chart, just recording the fractions of humans in our batch of subjects completing the sentence with the word cry relative to people completing it with the word complain, etc. Below you have the same kind of bar chart for a language model. Now, you can do this across the entire batch of subjects and for a single language model, but you can also do this for different demographics and take a lot of language models and compare them to our human kind of subdemographics. So this is what Victor's been doing. And so you can think of this as a way of evaluating the fairness of language models in some sense. So what Victor has been doing is he's defined groups in terms of age, gender, race, and level of education, all four kind of considered binary in his experiments. So you end up with 16 different groups. And then he just takes a bunch of language models and he looks at the discrepancy between the demographics, or basically the how well they align with the groups that they align the best with, and how well they align with the groups that they align the worst with. So the metric here is precision at 1. And basically, you can think of this bar chart as sort of the length of the bar says something about the overall performance, if you like, or alignment with humans of a language model. And the little bit on the right that's dark blue is the gap between the worst demographic and the best demographic. So you can think of that as sort of quantifying the fairness. So for example, if you look at these 5 language models, which is a small subset of what Victor's been looking at, you can see that Roberta Large, for example, generally aligns best with the humans, and is sort of medium unfair, I guess. GPT-2 and Electra align about the same in general, but Electra is much less fair than GPT-2, for example. Okay. Victor Hansen, who's a PhD student of mine, also in Coastal, has been doing some work to show that weight pruning generally hurts fairness, in the sense that the performance disparity between subdemographics increases the more you prune your models. So this particular plot here is from experiments with kind of lottery ticket style weight pruning, and the kind of the red line on the bottom with the dash blue overlay, kind of linear fit, is the difference between the worst and the best demographic, and relative to the percentage of weights pruned. You can see how that increases the more weights you prune. And this is for sentiment analysis. We're using the Trustpilot corpus here, and groups are defined by age, gender, and location. Now, in both the language modeling work here and the sentiment analysis work, we really rely on our data coming with information about the demographics of who wrote the text. And this is sort of my second point here today. Your benchmarks will enable this kind of research if there is information about the demographics of who wrote the text. Multiplicity, the idea of having multiple annotations of each data point, is the third thing that I'll mention here. So this is also something that we've worked with in the past, in work with Barbara Plunk and Dirk Hovey. We showed that having multiple annotations of data points, this was in the context of part-of-speech tagging, sometimes enable you to learn something about systematic disagreements that are kind of meaningful to models. And if you learn that and you make your loss function sensitive to these systematic disagreements, penalizing errors that are really maybe potentially not errors, but just sort of options in the context of these systematic disagreements, less than errors that are not. You can actually learn much better models, and you can also learn them faster. There's interesting results there too. This is something that we also explored in the context of dependency parsing. Now, in ongoing work by Tana Jakobsen, who's a PhD student I co-supervise. We've done similar experiments for argument mining. That is the task of detecting whether something is an argument or not. Here we're actually adding another dimension, which is that certain guidelines. So one thing is we're looking at annotator disagreements. We're also looking at the demographics of annotator disagreements. And we're also looking at how guidelines affect annotator disagreements between different demographics. So we basically end up with annotating the data a lot of times using different guidelines, using different annotators from different demographics. And we get all these interesting results where you can see that how well different demographics agree on how to annotate whether something is an argument or not depends on the guideline. It also depends on their political perspective. And so, for example, there's interesting interactions between whether you're liberal or conservative and whether the definition of an argument requires that the person arguing puts forward some sort of evidence for what is argued for. For example, okay, so point here is there's a lot of really interesting questions you can try to answer if you know the demographics of your annotators. It's generally interesting to have multiple annotations of your data points because there are systematic disagreements. But if you also have that additional information about the demographics of your annotators, you can start to look at, which is not something we did 6 years ago, but something that we're really interested in doing now. You can start to look at what sort of prompts these disagreements, what are they conditioned on, what sort of the reason for these agreements, and are there any potential biases in across the demographics of annotators. Okay, the final thing that I want to say is that you don't just want to do one benchmark and be happy. We don't want an entire kind of research community to rely on a single benchmark. In a paper, a Connell paper, a long time ago, we argued that just like when you train a classifier, when you come up with a classification algorithm, you typically you publish in some machine learning venue, you typically want to show that it's better than SVMs or neural networks or whatever on more than just a single data set. You want typically there's this rule of thumb to show that you're better on about a dozen data sets. So I have this pretty old paper arguing that we should do something similar in NLP. And when you have a part of speech tagger, you don't just want to be better on the Penn Tree Bank, but you want to have about a dozen data sets and show that you're statistically significantly better across data sets and not just data points. Now, I think it's interesting to think here a little bit about what a benchmark, really is. What's the etymology of the word benchmark? Now, a benchmark is a mark for accurately repositioning a leveling rod, right? Which is what a bench is here. In fact, when you do surveying, these benchmarks form networks and are used to draw height maps, right? So you're interested in portraying a landscape, just like we're interested in understanding how our models will do in a landscape of samples. Now, a single benchmark is not useful for a surveyor. It's just not. It doesn't tell you anything about um, the landscape, what the landscape is like, um, to know the height of a single point. Height maps rely on multiple benchmarks. You want to know the curvature of the landscape. Um, and this is perhaps I guess it's one of those things where there's a lot of people will be like, yeah, sure, of course, and a lot of people will be surprised. And I think to some extent it depends on how much you've experienced drift and how much you've kind of quantified the bias in a single data set. Now, if you look at something like section 24 of the Pentree Bank or something, um, you can be like, oh, sure, this is just a single newspaper, yada yada. Maybe, sure, it makes sense to have more test sets if you want to figure out whether one dependency parser is better than another. On the other hand, if take whatever the Danish dependency tree bank or the German dependency Dutch something, some of them are built on kind of corpora that compose different domains. Some even on corpora that are supposed to be representative, whatever that means. So you might be thinking that hey, if we have data that's not too crazy, if we have data that comes from somewhat representative corpus, maybe it's fine to have a single benchmark. And you actually do have that for a lot of NLP tasks. There's a lot of kind of mentions of the de facto benchmark in the ACL anthology. And I think kind of the likelihood of you buying into that idea, it really depends on whether you've experienced drift. And I think a lot of people in industry, for example, will be much more skeptical about the idea of having a single benchmark. So in this Connell paper, we argue that we need to compute significance across samples and not across data points. And this is really because we've seen, and this is also what we talk about in this EACL paper from this year, we've seen how much things change from sample to sample. I want to add one thing, which is that when you sample from the space of samples, you can do this in different ways. You can be more or less sort of adversarial, if you like. And I really like this word from this Liu et al. Paper of where they talk about being shift pessimistic, in the sense like we probably should try to expect the worst. And I think there's a lot of things you can do when you want to create multiple benchmarks to make them as different as possible. So one thing is that they need to be independent of each other. This is obviously very important for sampling in general, but you can also try to sort of go to different people to get the data, go to different demographics to get your annotators, etc. Obviously, sometimes you're interested in what we normally would call a single domain. That's fine, but even within that domain, there's going to be dimensions along which you would expect more variance. And this is just to make your sample as sort of efficient as possible, because obviously there's also going to be bias in how you sample samples. Although, hopefully, that biases can be small enough that it's better to compute significance across samples rather than significance across data points. All right, so this is basically what I had to say here. It's a very simple kind of half-hour talk. Your data is going to be more valuable to researchers. There's going to be more research that we can do with your data. If you add timestamps, if you add writer demographics, annotator demographics, if you can afford it, re-annotate the data. It's really, really interesting to see where the disagreements are. The disagreements are informative to models potentially. And especially, they might also tell us about systematic biases across demographics. If you have all of these things, also potentially demographics across time, if you have all of these things. And then if you can afford it, you don't just want to stop when you have a single benchmark. You want to have multiple benchmarks. So you should do all of this over again. Because we really need multiple benchmarks to be able to draw our height maps of NLP performance. Okay. I just want to mention, and this is really a shameless plug, but Victor, my PhD student, has a paper here at this workshop on guideline bias, and I think this is a really interesting bias. I mentioned in our work on argument mining, we're looking into the effect of different guidelines on how people annotate. What Victor does is that he sort of traces biases in data from guidelines and looks at sort of the impact of guidelines on the actual annotation without looking into demographics. And I think this is a really, really important thing to be mindful of in NLP. A long time ago, we came up with what I thought was a cool technique for doing frame semantic annotation without having very strict guidelines on how to do this. So in parsing and other complex NLP tasks, there's been a long tradition of kind of having very, very detailed annotation guidelines to make your inter-annotator agreements as high as possible. I think what I'm arguing here, and this is a little bit in contrast to Sam and George's paper, is that this potentially introduces a severe bias. This bias may also interact in interesting ways with demographics, the demographics of your annotators, maybe also the demographics of the authors, but definitely the demographics of the annotators. So, if you introduce guidelines, if you use very detailed guidelines, you probably want to use more than one set of guidelines, or alternatively, like we did back then, you should try to make your kind of approach to annotation as guideline free as possible. But of course, this will mean that you will get kind of less accurate annotations. It'll mean that you'll get more ambiguous annotations. But I actually think we should embrace that ambiguity, embrace that lack of precision, embrace the variation that comes from having a lot of people annotate your data with very different ideas of how that data should be annotated. Because I think a lot of the kind of the very detailed parts of your annotation guidelines are pretty arbitrary. Okay, so this is what I had to say. Just go back to the slide, it's sort of the summary slide. Yeah, if you want to have more arguments for all these 5 different ways of improving your benchmarks, I've added references to the slides, and I'm happy to, of course, discuss all of these in the discussion sessions during the workshop.